All right, there's a couple things we're working with. If we end up doing work, we're talking about applying a force through a distance, and that force and distance have to be in the same direction. If they're not, then it's a torque, and that's something else entirely. All right, so force being applied through distance. If we do that, that work is gonna end up changing the amount of energy in the system. Typically, we're going to deal with mostly two types of energy, and we might refer to a third we'll talk about here. So you're either going to change your potential energy, and I'm going to get specific with this because potential could be gravitational, as in you're lifting things up, gravitational, just enough room, or elastic potential energy, which means you're stretching a spring or a rubber band or that type of thing, something that's going to pull back when you change its position. So potential energy is always based on position. If we're talking gravitational, that position is height. If we're talking elastic potential energy, that's from a spring or a rubber band. That gets stretched or compressed, but it's always going to push back based on where it is. So that's potential energy. The other way you can go, if you do work and things starts moving, now we're talking about the Greek word for movement, kinesis, or kinetic energy. All right, so if we're dealing with kinetic energy, we're dealing with the mass and the velocity, specifically the velocity squared. All right, so we have one equation with work equals force times distance. We have another one, which is the work energy theorem, fancy name for saying, hey, you did work, you changed the energy. We have kinetic energy equals 1/2 mv squared. If you want the derivation for that, the Khan Academy videos do a great job of that. I won't redo that here. And we didn't do potential energy. So potential energy gravitationally, let's scoot this over. So gravitational potential energy, which on most of the time I'm going to refer to it as PE because that's usually the one we're dealing with. On positive physics, this might be referred to as GPE, gravitational potential energy, as opposed to EPE, elastic potential energy. All right, so gravitational potential has to do with mgh, or basically your weight times the height that it gets lifted. Sounds very similar to work, not an accident. If you're curious, elastic potential energy has to do with a spring constant and the position that gets changed, but we're not going to do a lot of work with that. There is a relationship there. That's outside of the scope of what we're going to be dealing with. So let's zoom out a little bit. Just a quick review. We have work equals force times distance. We have the work also changing the energy in a system. The kinetic energy is going to be 1/2 mv squared. That's based on how fast something is going. And the gravitational potential energy is mgh, based on the h being the height that we're looking at. That's kind of the four big equations we're dealing with. Oh, one more thing. If you want to know how fast all of that is happening, then we're talking about power, and that's how much work you do or how much change in energy happens over time. Ta-da!